Hey guys, it's Roya, and today I'll be talking about work and variable force. So if you remember from a previous video, work equals F times D, which is force times displacement. If we were to look at a graph of force and displacement, and if we were to have a constant force, and say displacement were 50 meters and force were 10 newtons, then in order to find the work, if we multiplied 10 times 50, it would be the same as taking the area under the graph. So work would be the area of this rectangle, which would be 50 times 10, which is 500 joules. So that makes sense. Now what if force were variable? From the equation F equals ma and the equation delta x equals 1/2 at squared, we can see that force and displacement actually have a direct relationship. And this is because if we rearrange this, we get a equals 2x over t squared. And if we plug all this in over here, we get F equals m times 2x over t squared. And the only variables we care about here are f and x, and as you can see, they're directly related. So, if we were to draw a new graph of force and distance, and say we started at 10 newtons and wanted to get to 40 newtons, the graph wouldn't look like this, and it wouldn't look like that. It would just be a straight line from 10 to 40, or a direct and linear relationship. So if we were to use this variable force across a displacement of 50 meters, just as before, we could do the same thing as before, taking the area under the graph to find work. Therefore, we wouldn't have to do any messy calculus with this changing force. And we just get that work equals the base, which is 50, times 1/2 of the two heights, which is 10 plus 40. And this is the area of a trapezoid. And if we were to do that on our calculator, we'd get that work equals 1,250 joules.